We have this question right here. It's asking find dimensions of a rectangle with area 1000 meters square whose perimeter is as small as possible. So let's see how we can do this. So first of all, we have to draw a diagram for this picture. So let's see how it's going to look like. So it's going to be something a rectangle, right? They are mentioning it's a rectangle, and it's going to have something like a dimension. Let's say this is x, and let's say this is y, and they are asking to find the perimeter as small as possible. So perimeter, so equation of the perimeter is going to be equal 2x plus 2y, right? So that's going to be the equation, and they are giving the with a rectangle with area 1000 meters square. So according to this diagram, that the area is going to be x times y. So in this case, x times y is going to be equal to 1000 meters square. So our purpose is to find the perimeter that is small as possible, right? So we have to take this equation, and we have to find the derivative, because the derivative will, if we find the derivative and equal is to 0 and find the x value or y value, that's going to give us absolute minimum with the critical point. So from that one we can calculate the absolute minimum or absolute maximum, right? So in this case we have to find the absolute minimum, therefore we have to find the derivative critical number anyway. So in this case I am taking this equation 2x plus 2y, but in this case, if you see, we have two different variables. We have x and y. So we have to bring everything in one form to find the derivative of this one. So what I can do is, if you see the area equation, xy equal to 1000 meters square. So from that one, I can find the y in terms of x. That's what we want. So if I find this one, it's going to, y is going to be equal to 1000 over x. Now what I can do is I can substitute this y in this equation to find the derivative. So let's see. So 2x times 2 times, instead of y I'm putting this 1000 over x. So if I put that one, I will get 1000 over x right here. Then it's going to be something like this. Then what I can do is I have to find the derivative of this one. So to find the derivative, I can simply write, let's write in one more step. So 2x plus 2000 I write this one x minus 1, so it will be easy to find the derivative. So is x minus 1. So derivative of this is going to be just 2, and derivative of this is going to be minus 1 minus 2000 x minus 2. I'm using this formula. So x to the power n derivative is going to be equal to nx n minus 1. This is a general formula to find the derivative, so I'm using this one right here. So since we have the first derivative, this not this, so this is my first derivative, and now to find the critical point I have to equalize this one to 0. So if I equalize this one to 0, let's see what we get. So from this one, if this is equal to 2 over 2000 over x square, what's gonna, if I bring this one to the other side, it's gonna become uh, plus, okay, so I continue in the other side, so it's going to be 2000 over x square is going to be equal to 2, then 2x square is going to be equal to 2000. From this one I can say x square is equal to 1000, and x is going to be equal to square root of 1000, and it can be plus or minus, but in this case what also if you see the derivative, if you see a derivative that's dividing by x, there's another critical point possible, because in this case if the x value is 0, that at that time the equation does not exist, because so that should be included as one of our critical points, but we don't include it, because if you see the dimensions x and y, like if x is equal to 0, that doesn't make any sense, because if it's 0, the diagram does not exist at all, because the length, we are calculating length, if the length is 0 or negative, there's nothing. So we can say x is always greater than 0. X is always greater, that's going to be our domain. Therefore I don't take this critical point, because that's not in the domain. But in this case here also same thing, plus or minus the root 1000, I can't take the minus, because minus is not in the domain, because x is the length, we can't dimension something in the negative value, right? It's going to be always positive, therefore I have to take the plus 1000 plus root 1000. So this is going to be my dimension, and I have to check. So this is my one dimension. I have to check whether it's absolute minimum maximum, because in critical point two possible. One one can be absolute minimum or absolute maximum. We don't know. So to find that, to make sure whether it is absolute minimum or maximum, I have to check the double derivative test of first derivative. Double derivative is much easy because in the double derivative, if you get a positive answer, it means the parabola is opening up. It means we are going to get the absolute minimum. If we get negative answer, the parabola is opening down, therefore we will get absolute maximum. So in this case, they are asking for the perimeters that's small as possible. Therefore, we have to get absolute minimum. So in this case, I have to get a uh, I have to get a positive number to for this answer to be true. So let's see whether we get the positive number. So first of all, we have the first derivative right here. I'm copying right here. So now p prime is equal to 2 minus 2000 x minus 2. So if I find the double derivative, let's see what happens. So if I find the double derivative, this is going to become 0, and this is going to become minus 2 times 2000 x minus 3. So it's going to be uh, plus 2 times 2000 over x cube. And in this case, there are two possibilities, because since this is x cube, if it's an even number, we always know that the even number square, like for example, if it's square, we know it's always going to be positive. But if it's an odd number like 3 or 5, x to the power 3, it can be negative or positive. But in this case, we have to consider the domain, because a dimension can't be negative at all. We know it's always greater than 0. So in this case, this is going to be this must be positive. Therefore, this answer is going to be positive. Therefore, from this we know this parabola is opening up. Therefore, we know this is absolute minimum. Our dimension is right. This is going to be my answer. So since this is the answer for the question, so they are asking the whose perimeter is as small as possible. So we have x right here. So to find the y value, what I can do is I can plug this in the y equation. So if I plug it, I will get 1000 over root 1000. So 1000 over root 1000, I can write the 1000 as root 1000 times root 1000 over root 1000. So root 1000 cancel, and the answer is root 1000. So unfortunately, it's going to be a square. It's not going to be a rectangle, because x and y are equal. So this is going to be a square. However, that's going to be my answer. So if you want to find the perimeter, you simply multiply this 2 by x, 2 by y, and calculate the value. That's it. That's how we do this question. I hope you guys like this video. See you next time.